Hello everyone, I am Suhas NLP stream owner at ACE, and I welcome you all to another spotlight session. Today's session will be about the AI product lifecycle. Most of our sessions are focused on the research and engineering aspects of AI, but as you know, this is just a small piece of the puzzle. Building an AI product encompasses a lot more stages, and today's speaker, Sekhar Maddula from Queen's University, is going to shed light on that. Hello, Shekhar.
Hi, Suhas.
Hi, please introduce yourself and looking forward to your presentation.
Yeah, sure. Thank you so much. Hello, everyone. Good morning, good evening. I don't know which part of the world you are. Today we are here just to have a chat, I would say, on the AI product lifecycle. Before that, let me introduce myself. I'm a full-time Masters of Management in Artificial Intelligence program student at Queen's University, Canada. And I feel I am qualified to present the talk today because of these points. I have like more than a decade of experience in IT product and consulting, carries like 6 to 7 years in the AI analytics experience, worked for Accenture as an associate AI architect. I filed 2 patents and I implemented a custom version of Snorkel algorithm or the product from Stanford. So the objective is to discuss all important aspects of the AI product lifecycle. And let's take a look. What are the life phases here? By the way, while we proceed, you can keep giving or asking the questions in the chat or whatever, and we can take up either inline if it is a thing, if it makes a lot of sense, or we can take up towards the end. So the first phase starts with like a solutioning, and then it goes to the architecting, implementation, delivery, and we also have a couple of other phases like strategy, costing or pricing, project management, and people management, and client management. The illustration here is just to show you the kind of phases we have, not literally in the order, like one after the other. And if you see a strategy, it has like a 2 stars, and it's present everywhere. We have to consider that in all the phases, not only after delivery kind of thing. And also, if you see a costing or pricing, project management, people management, and client management, they are support functions. You don't get any tangible kind of output with all these phases, but you get a tangible output everywhere else, like a solutioning, architecting, implementation, delivery. So when we talk about AI project or process flow, everybody thinks that whoever has a kind of a fair amount of usage experience or a knowledge on the AI or data science project, they think like, okay, data collection and feature engineering, or maybe cleanup and then exploratory data analysis, modeling, and all that. I'm not going into that cycle because already there is a lot of content available and everybody are aware of that. And the flow that I'm showing right now, I would say is like one of the most matured and most exhaustive flow delivered by the aggregate intellect. And there is another video, you can take a look at that. Now, coming back to the original process, like it starts from a kind of a business process, and then it goes to the collection. And while data collection, you face a lot of issues, technology specific or process related or whatever. And then you ingest into the platform where you want to run the models. You do exploratory data analysis, feature engineering, machine learning, testing, and delivery. So this is a typical life cycle with a little bit of changes depending on the project or the process that you are working on. Now let's take a look at the solutioning. And the solutioning ideally is a kind of a process of finding a solution to a problem or a difficult situation that we all have been doing it even without AI in our regular day-to-day life. But to me personally, I feel it like it's an art more than a process. Because why I feel it as an art? Because it's not like a fixed rules or guidelines. That's why I consider it as an art. So we will get the clarity as we move along why it is an art and all that. So as we know that it's a process or an art or whatever, let's discuss about the different aspects in the solutioning. Most of the times when we go to a client or when we think about making our own AI product, most of the times we don't know what exactly is the problem to address. Even if you go to a client, he may be making a statement saying that, hey, I want to do this, but you are really not sure whether that's the same thing that you are going to address it in your AI solution or AI product. You have to be in a kind of like constant discussions, multiple rounds, and you must be asking so many questions like why, how, what, when, and where, sort of things, all sorts of WH questions. And it is not a one round. You have to go into like a multiple rounds of discussion along with the exploratory data analysis and stats and all that, along with the storytelling. So it should happen thoroughly, repeatedly throughout the cycle. When you do this exercise, you would realize many a times a few solutions could lead to a change management related things, and then few could go to a digital transformation wherein you may be making a kind of a product or a solution. And after that, you get into a acceptable metric. When I'm saying metric, it's not the precision or the recall or F1 score kind of thing that we all know in the machine learning community or the AI community. This is a kind of metric where they need to decide whether I should take the solution, whether the client should take the solution. Maybe a kind of reduction of time in a process, or a kind of like a save in the dollar value, or whatever. So that's the kind of project acceptance criteria. And when a person is going for a solution, he should not be feeling too much interested in the kind of AI tools. He should rather have a mindset of solving a problem with the client. Like, unless like, hey, I'm too much interested in the neural networks, I want to deliver a solution on neural networks all the times, or maybe I'm interested only in mathematical modeling. No, not of that sort. I personally feel like a 30% of requirements as on today, those can be solved with lexical or rule-based solutions. You don't need really a kind of artificial intelligence kind of algorithms or something. Let me quickly give you an example what I mean exactly by a rule-based thing. If you recollect the approach of a regular expressions, it's a rule-based one. It's just a pattern match, and it's a kind of a rule-based one. And there is no probability concept involved at all in the regular expressions. Whatever results it's giving, it's 100%. No false positives and false negatives, right? But rather than that, if you go to any of the AI approaches, every algorithm or a methodology has a probability component in that, and it's going to be like certain to some percentage. Your solutions are accurate, maybe like 80% or 85% or 90%. But unlike in the rules or lexical based approach. That's one kind of solution you can give, and the other kind could be like a change management, as we discussed. Like, it could be a change in the existing process of the client, so on and so forth. And it could be a mix of both of them. So that's where you see like part of it goes to the change management, part of it goes here. And when we are having a discussions continuously, multiple rounds, back and back, and sort of thing, uh, obviously we all know that we have to have a subject matter experts or the important stakeholders in that. And another important factor that's emerging in these days is explicability and ethics. So especially in the insurance industry or the financial industry, or a kind of healthcare related things, where you need to explain why the machine has taken this sort of decision, and why you are supporting or going with the decision taken by the AI solution or a methodology. You have to have the explicability factors. And also, not only the explicability, you should have ethics kind of thing. We all know that so many situations are happening around the world, especially in the United States, around what's going on with respect to the ethics. So these are all very important factors when we try to implement a AI solution. And we should not be like fixing up with one kind of a solution, because you never know what kind of problem you may be hitting down the road. So it's always a good idea to have multiple rounds of multiple alternatives of solutions, so that if one situation becomes a hurdle or a roadblock, then you can take a alternate route and move ahead. It's especially important to do this exercise at the phase of solutioning itself, rather than deciding later part of the phases. Now let's move ahead on the architecting. And so there is a acceptable framework, the open group architectural framework. Developed by the Open Group company, and there is a certification delivered by the Open Group with respect to the architectural framework, and it gives you, once you are passed in this, you get a fair amount of knowledge on like how to architect a problem, how to architect a solution given a problem in the technology space, what kind of aspects we have to look at it and all that. But I'm not going into the details of this framework now. I have made like a gist of those points, and these are like 5 aspects we should be looking at when we try to make an architecture here. So the first one is the business architecture. As we all know, like it's a kind of a business one, and you get to know like what are the use cases, how use cases are connected, and how this business is connected in the existing ecosystem of the IT infrastructure of the client, and all that. One thing I want to mention here before proceeding is when we say that we are trying to build an artificial intelligence solution, we most of the times we build a solution and put it and try to fit it in the existing ecosystem of the client's IT infrastructure. So that's why it's very rare that we try to make a completely silo AI solution altogether, but we have to try to fit it in the existing system. So when we are developing an architecture, could be any of these varieties, we have to think about all those other aspects, and we have to show that we have to draw the architecture in terms of the existing ecosystem. Excuse me. So that's the business architecture. And when it comes to the application, the kind of application we are developing, how this application is connected with the ecosystem, how this application is connected with different systems like SaaS or SAP or ServiceNow, other systems in the client's IT space. And that we have to mention it very clearly. We have to understand how these are connected. This is very important here because most of the times when we try to get the data from the other systems, we have to understand how the connectivity is established. These days, every product is providing a kind of API, maybe like a Python API kind of thing. You can establish the connectivity with the privileges once you get that, and then you can try to run your algorithm or the model. The third one is the data architecture, where you may need to extract the data from across the systems. Maybe part of the data from system product A, part of the data could be from product B, so on and so forth. So that's why this data architecture is important. And the fourth one, when it goes to the technology architecture, you need to understand like what kind of technologies we are going to make it. Are there any issues with respect to the inter-technology communication or inter-technology aspects we should be considering and all that. The last one is the deployment architecture. So this is, I would say, a very important one in terms of primarily 2 reasons. First one is the security, and second one is the scalability. Let's assume we are not maintaining any kind of layers and we are opening up our product to the outside world, and we all know what's going to happen. And every organization or a company has their own system of principles with respect to the security. So we need to develop the deployment architecture in alignment with that. And similarly, the scalability also comes to the same thing. So we don't know what kind of demand we would be facing. We have to have a kind of an idea, and we should think about like what happens if we go beyond a certain limit, and we try to provide a solution to the wider number of audience. So in all these 5 aspects, we should be building like what is the current architecture and what is the proposed architecture, and then we can think about like the next phase. Guess what? So it's implementation. So now it's time of actually making the hard code, actual hands-on development, right? Now we need to decide a kind of hardware we need, or if we need any softwares which are like a license-based one or something like that, or maybe we may be looking at a cloud licensing aspects. All these things we have to start looking in the implementation phase. Few clients may be okay to go with the cloud solution. Few clients may say, no, I don't want it. Rather, I want to have everything on my premise. I don't care about the cost or budget. So for them, they don't have a trust on the cloud solutions yet, so they don't want to go with that. So that's why these are the important factors you need to evaluate and go with that. Then once all these things are set up, what do we do exactly is we try to build a minimum viable product, or many people call it as a POC, proof of concept, and then say that, hey, this is what I have done and all that. So these days, minimum viable product is like a little bit obsolete. It's people are calling it as WMVP, where it is like actually whole minimum viable product. There is no big difference between these two, but one important difference is like when we say that we have made a POC, we created a POC, or we created a minimum viable product. It says that you have done an important part of the model, and then you move ahead. But in the whole minimum viable product, you just don't confine yourself with the one feature, with one core feature. Rather, you try to see what are the other important features which look like a mandatory one in the solution. So then you say that, hey, this is what it is done. It's very important to impress the client or the product owner when you say that I have built something. And industry is evolving from POC to WMVP phase now. And let's move ahead and see the kind of environments we need to use it here in the AI product. It is the first one is the research and development, and second one is the development, test, UAT, and production. I think these are all self-explanatory. I don't need to. I guess I don't need to get into the details here. So as we discussed earlier, we may be having multiple other applications in the client ecosystem. Could be ServiceNow, could be SAP, Remedy, Oracle, Hadoop, or Hortonworks, whatever. And we may be trying to build a framework or the solution on premises, or maybe on the cloud, maybe with public, private, hybrid, whatever. We need to identify the kind of APIs that we are going to try to use it in the solution. This exploration of APIs, to me, takes a little bit of time. We should be paying a fair amount of attention here. I know everybody are providing their own APIs, maybe in Python or some other language, but to explore how exactly that API can be used, what kind of user credentials we should be using, and getting those things created by the administrator of those platforms, all those things going to take some time. So we have to consider this aspect while we try to work on the implementation. Now, till this point, it looks like we are focusing on the surroundings of the so-called actual AI product, and then now we would be moving on to the actual implementation. Could be like obviously we would be trying to make this one in terms of multiple AI models or solutions in parallel, or maybe in sequential. The output of one model, you feed it to the model 2 and model 3 and so on and so forth. Kind of like first you may be doing a clustering, and the clustering you may be feeding it onto the time series, so on and so forth. So these kind of things we all need to consider that when we try to work on the implementation. And similarly, when we talk about the next point, it's inter-algorithm dependencies or issues. I just want to quote one example. If a person is already aware of kind of working on the data science or AI projects, they must be knowing this. But if you're trying to work on a kind of PCA on a data set that is delivered by one prior algorithm, which has a near zero variance kind of thing, you may run into issues when trying to do a PCA. So that kind of aspects we need to consider that. Otherwise, like we see that, hey, I have run this and it's throwing me error and I can't proceed it now, and you have to change the prior algorithm output or whatever. So that's another important one. And the last one in the screen that we see is IPs and patents. It's another important byproduct that we get it while we are trying to work on these implementation things. So let's take a small pause here and try to get a little bit deeper onto this IPs or patents to understand this one better. I know everybody in the artificial intelligence community, they're trying to make really, really interesting and innovative aspects in their work. At the same time, when they try to do that, everybody feels interested if they preserve their intellectual property. So I would say there are like 4 different sorts of intellectual properties. First one is a patent. and trade secret, copyrights, and trademark. I'm not getting into the deeper aspects of how these are, what are these, how these are different, which one suits the best, and all that. Maybe if majority of the folks are interested, we can take a next talk. But these are primarily four different sorts of intellectual properties. So and obviously we would be looking at like what kind of thing I can really try to make it as a patent. Many people have confusion or a question in their mind. They feel like they have innovatively identified something in the AI space, but they might be having question like, should I go ahead and file a patent? It's going to have a cost, right? So patent is a costly process, and of course a time consuming. Clarity on that point, you can do a patenting on one thing is the technological innovations, and second one is the application of technology, and third one is the business innovation. So any of these three varieties you can do a patenting on this. So that's the difference between all these three things. And one more thing is we may be thinking like when I should patent it. Should I be doing the day I got the idea, or should I be doing this patenting when I have the actual implementation ready? I would suggest go on the point one. When you get the idea, you can always go with the patenting of your idea. You really don't need to wait for the actual implementation to be completed before filing a patent, because that itself is going to take a lot of time after you file the
Sorry,
patent.
Sekhar.
Yeah.
Just a clarification question. Can you please repeat what are the four different types of IPs that you mentioned?
Okay, sure. Yeah, sure. So
Yeah.
first type is the patent. That's the type one of the intellectual property. And second one is the trade secret. Third one is the copyright. And fourth one is the trademark. So these are the four different varieties of intellectual properties.
Okay. Thank you.
Yeah. And so once we are there till that point around implementation, we may be looking at other aspects like globalization and localization kind of features, wherein you may need to change your product according to the geography where the customers are using, maybe adjusting the date and time with respect to the daylight saving time, or maybe localization of languages, so on and so forth. The next one is bias and explainability. As we all know, the explainability is very important. We just discussed like a couple of minutes ago, and bias is also equally important. Entire machine learning community is eagerly studying this bias and other ethical aspects. We maybe need to look at the aspects like what kind of explainability framework we are looking at. Example, I just mentioned one framework here, Lime, which is like a local interpretable model agnostic explanations. I'm not again going into the deeper aspects of each and every algorithms kind of thing here, but I'm just trying to mention over here that explainability framework to be considered here is equally important when we try to do the implementation. And then the responsible AI ethics and trust index. So trust index is a very innovative aspects in the AI ethics. I would say it's one of the most latest in the industry. So when I say the trust index, let's assume your architecture has like 5 layers, maybe like 5 layers or 10 layers, and you need to identify what is the trust at each layer. Like for example, if I am exposing layer one to the maybe layer one to the customer, what is the confidence or the trust in layer one to me when I'm trying to expose it to the customer? And if I personally feel that the layer one is not trustworthy, then it doesn't make any sense if we try to expose it to the clients. And the trust index, as the name says, it's a kind of a quantification on how you build a framework on evaluating the trust and across the layers. And the trust index, the scaling could vary from one layer to the other layer as we move along. If a layer is If a layer is a kind of only UI, then it's only like how the data is being coming into the solution or something like that. Or if a layer is on the aspects of like model development, probably let's take an example like a neural nets. What is the trust on the predictions or the interpretations the model has made? Uh, we all know that it's a black box, but at the same time, how confident I am when I'm trying to build a solution and deliver it to the client. So that's why trust index is important here. And the next one is audit and compliance, or privacy and data governance. So these are all very important factors. When something goes wrong, that's when all these things come into the picture, right? Audit and compliance comes in there, and privacy or the data governance are varying from one place to the other place, depending on the geography and all that. But these are important aspects to be considered while doing the implementation. Again, the last one is scalability. We all know the scalability issue, how the things go on. All of a sudden, we all know that how the world has changed once the corona has hit the world. It hit the world. Everybody has moved on to Zoom, and it's a kind of zooming of their users count. So obviously, when again normalcy comes back, people may not be doing that, and that's where we need to look about aspects like elastic scaling. How can I handle these things? So we know there is a whole world of applications and products coming in, and this list is not complete. It's like keep evolving, keep emerging. Whatever product we may not be seeing today, all of a sudden you may be seeing it like a week to 10 days down the line. So what I'm saying here is when we are trying to implement the solution here in the AI solutioning, it's always good to have the knowledge of the different products emerging in the industry. Every product has its own differentiating feature, right? So if we have the knowledge of that product, then we got to know that, hey, there is a product, we don't need to reinvent the wheel, we can just use it, and we can make it as a quick development, and we can reduce the time to market or cost kind of factors here. So that's why knowledge or the awareness of what's happening in the market is really important. And so again, here is the simplicity is the best policy with respect to so many reasons. We all know that. But again, I'm quoting a Gartner slide here. Across the presentation, I'm going to quote many places. I'm going to quote the slides shared by the Gartner, just to show that whatever we all are thinking is in line with the industry. That's why I'm quoting it here. So we all know that when we say simplicity, the lower rectangle of algorithms are comparatively simpler and explainable than the upper rectangle of like a bunch of DPI aspects like reinforcement learning, recurrent neural nets, and deep neural nets. And here you see a KNN, support vector, regression, so on and so forth. So that's why I'm just trying to discuss the point here. And so the next one here is what kind of products are available in the industry, right? We know that most of the products are still evolving, and whatever product we don't see today, we may be getting it like whatever the future time down the line. But if you see a kind of this magic quadrant published by the Gartner, we can feel like Databricks, SAS, or Alteryx are like kind of like leaders in this space. Of course, everything comes with its own set of advantages, disadvantages, and cost factors. We have to identify which is like the best suitable framework or the solution for our product. Now, assuming that we have all these things in place and we could progress fairly on the implementation aspects, the next one would be the delivery. Now, with the delivery, so let's try to understand what exactly I mean by delivery here. We all know that in the software, delivery kind of thing starts once we deliver the solution to the user acceptance testing. But I personally feel that delivery starts from kind of like day one of implementation in the AI space, because because most of the AI projects we cannot have it on a fixed billing kind of budgeting. We have to have a time and material because of so many reasons. We are going to discuss those aspects down the presentation. But just because it is a time and material, client would be so much interested to understand what kind of development we are making on a daily basis, and are we progressing, are we stagnated, are we just eating up the budget. He would be very curious to understand. So that's why in terms of delivery, I personally feel it starts from day one, and it's good to share the daily updates of the progress with the client in so many reasons, like to maintain the confidence level of the client and so on and so forth. So once this implementation is done, then we think about the delivery, and in the delivery we got to the stage of like product maintenance and model maintenance kind of things. So we all know what exactly mean by product maintenance. We deliver it, we find some issues, and the issues will be logged in the system. Development team tries to fix them in and all that. But when we go to the model maintenance, model artificial intelligence model has its own time, and it's not like you make it once and it is available forever. It has its own time, and it would definitely become obsolete as the business evolves, as the client base evolves or changes, or maybe the preferences of the clients changes. So when the data changes, the model that was built on the older version of data, that may not be valid any longer. That's, we call it as like model drift. These are the kind of aspects we must be looking at by looking at like the drop of accuracy or a drop of F1 score, whatever the metric we were considering. Those will show like drift in the model that we built. That's another important aspect we should be looking at constantly. Otherwise, your solution becomes like obsolete pretty soon. So these model maintenance and product maintenance are handled with respect to these development operations and machine learning operations in terms of constant renovation or improvement of the model and the product. And depending on the size of the product, I would say the first two to 4 weeks of time is really the key. When the client actually tries to start testing in the user acceptance testing environment, there is a high probability that you get like 70% of issues in that time frame. So we have to pay a close attention during the time frame when we deliver the AI solution. And this is a kind of like a very quick illustration of any of the AI or data science kind of projects in terms of the machine learning operations. We start with the business understanding, and then we go to the data sources discovery, collection issues, collection things and all that. And then you do a wrangling of the data, you do analysis, and then you build the model, and then it goes to the model evaluation, model validation. So from here, it could follow this cycle or it could follow this cycle. Again, you may need to come back to the data wrangling, analysis, validation, so on and so forth. Or it may come here and then go to the here new data acquisition, sources, so on and so forth. Or maybe you come here, updating your business understanding, and then repeat the cycle. So this is like one side of the slide. And other side is like once you feel that model validation is good enough, then you go towards this cycle, thinking that, okay, you make the model activated, and then you make it deployed, you integrate with the application, production audit purposes, model behavior tracking, and KPIs for validation, and so on and so forth. This is like two cycles, two adjacent cycles, closely connected. It's going to show like the complete flow of machine learning operations here. Now, we have seen the solutioning, architecting, implementation, and delivery. All the four phases have its own tangible outcome. And now we are looking at the strategy. As I have mentioned, strategy is everywhere of all the other phases, both the tangible and intangible phases. But here I'm going to show like a couple of slides to give a kind of word of caution for us to understand where are the places where we may need to play a little bit more focus on planning and implementation. So the first one is talent gap. So we know that artificial intelligence is still evolving, and it's not a surprise to feel that there is a huge gap in the talent. And ideally speaking, if you are working on any AI project, we would never start the project till we reach a complete talent availability in the team. Most of the times, we keep evolve the knowledge levels of the team and we move ahead. That's how we go with that. That's the best practice instead of waiting for complete talent to be available. And the second one is bias, compliance, and ethics. So it looks like a repetition here, but it is a very challenging aspect, and it could throw us into a kind of pitfall if we don't focus on that appropriately at the right time. And the third one is entire community is aware of data quality issues. So we have to live with that, and we have to strategize how we can handle the lack of quality in the data. That's another important one. Model operations and scalability and fear and misunderstanding. So this I would say another important one is when we try to start the discussion with the client, maybe on the day one or anytime during the development phase, we would face challenge in understanding in the first round. So we may need to go with the multiple rounds to get a fair amount of understanding and to get into the implementation. So this is like a kind of challenge. We have to live with that. This is a kind of, I would say, limitation. It takes its own time. Nobody can avoid that. Rather, we have to be prepared. Okay, I'm going to make like 5 rounds of discussion with the client. That's what is the thing. And second thing is the next thing is like user inertia and analytical status quo. So when I say the user inertia, it's a kind of, I would say, user experience kind of thing. We have to consider different aspects. At the end of the day, whether we are making an artificial intelligence solution or any other solution, at the end of the day, it's being used by a set of users. And unless we try to do a user experience better, we cannot expect the product to be successful. So that's another important one to be looked at here. That's not the end of the story. As per Gartner, there are like other bunch of pitfalls. Like talent, data, model, and evolution of technologies, so on and so forth. That's not the end of the story. There are so many other pitfalls. So how can we try to kind of come out of these kind of things, limitations, right? So we have a inventory of data science skills and ambitions. We have to look at that and strategize our approach. Data sources and their quality, depending on kind of data source you have to work upon, and deployment tools and technologies. Basically, it's a kind of like you know more and you can easily come out of those limitations. That's the gist of this kind of recommendation slide. And don't go by hype or semantics. Stay focused on one point and start focusing on one point and stay focused till you solve that. So that's a kind of like thumb rule for coming out of these cycles. And the next thing is understand the data science and machine learning landscape and your options. So that's like keep open mind all the time throughout the cycle. Always look first at the buy option, right? So this is another recommendation. And be prepared for significant staffing and communication challenges. As we all know, like, so to me, AI engineers are, I would say, like very scarce resource in the market. And if a person leaves your team, what's going to happen? You have to be prepared for that in terms of those kind of situations. We are going to discuss a little more in the people management, but it's another challenge that we should be prepared in the development. Now, having discussed all these things, let's take a little focus on costing or pricing, where we try to understand how do we price the development activity, or how do we try to cost this entire thing. So there are two important components, like in any other IT solution. There are two important components even here too. First one is the technology, and second one is the people. These are the only two costly matters, costly factors, cost factors in the IT development. If you look at this graph here, on the leftmost side, on the pointer where I'm showing here, this is like a kind of cost and sophistication at the minimum. And towards the right, along the x-axis, we are increasing the sophistication. And while we move towards the right side, along this y-axis, if you see the cost, when you try to see the cost is increasing. On the topmost sophistication and cost side, you have deep learning hardware and deep learning cloud platforms and all that, or maybe data science and machine learning platforms. When you say the platforms, it could be like a SaaS or Alteryx and all that. But you have a wide variety of platforms and solutions available in the market. And we should be looking at what is our budget and what kind of quality we are trying to achieve at the end of the solution. Based on that, we have to decide which solution we should be picking up. So if you see this four quadrants here, assuming that quality is the depth that you are traveling and the price is the kind of width you are trying to cover, if you are going too shallow, not covering too wide, not going too deep, that's a kind of economy quadrant. But on the other side, if you see you want to go too deep, at the same time you want to cover too wide, that's the premium kind of development activity that you would be doing in this. The penetration is kind of you are going too deep but not too wide, and the skimming is you are going too wide but not going too deep. So why we are discussing this is the technology we might be using could be off the shelf, like tools available in the market, or we are trying to make something in house. Either the way, depending on what is the selection of our quadrant, it's going to cost accordingly. So that's why we have to look at this aspect when we try to budget the price, when we try to price the development here. So as we discussed, fixed price budgeting may not be suitable at all, because we never know. The requirements are not easily frozen. That's the same story with any IT development activity, but in terms of AI, it's a lot more. It's a lot more, excuse me. And the set of requirements keep changing as we move along with the exploratory data analysis or descriptive analytics, as we make these things mature. As the maturity increases, you may be identifying new requirements which you feel really required in the solution. So that's why the requirements keep changing, and the cost would keep changing, and the time also would keep changing on that. And one another important point when we try to develop a solution here is the metric. So assuming that you have developed half the way of the solution, you have implemented in the coding and all that, with the focus on, for example, let's say accuracy. And in the middle of the journey, you discussed with client and you have shown something, and at the end of the day, he asks like, no, I don't want accuracy anymore. I want F1 score. Just with that simple change, believe me, it's going to make a lot of rework, starting from the data collection till the model building. So when it is making that much change in the cycle, obviously it increases the time. You may need to change even the tools that you are selecting if client is looking for a different metric as a whole. So that's why this is a very important one in terms of what kind of metric we are using. And when we are agreeing with the client in terms of a new metric that client is proposing, we have to keep a thought process on the back of our mind, saying that, oh, I may need to change the technology platform as a whole, which is going to change total budget as a whole. So that's another important aspect we should never be forgetting. And buffer slippages are like quite common in AI development. We have to be handling that in a very judicious manner. Otherwise, it's going to eat up the complete budgets and the time. All right, now we discussed all the important phases other than the support functions. Even now we looked at the cost, which is again a support function. Let's take a look at the project management. How are we going to how are we going to do the project management specifically for the AI. So first one is work pipe planning. People may be thinking that why work pipe planning is so special with the AI projects. I would feel that every project is special. Let's assume you have a team of like maybe 20 AI engineers, and you're working on a project, and the project one is about to be finished, maybe like 1 month or 2 months down the line or 3 months down the line, you're about to be finished, and then you would be taking up a new project. Just imagine a situation wherein you are keep on accepting only a kind of natural language processing related projects all the times, only NLP. And even in NLP, you're, for example, if like you're focusing on kind of chatbots, right? So just consider the situation of your team. They it takes no time for them to feel like they are stagnated in terms of their knowledge development when you say that I'm working on all the times on chatbot projects. So that's why this work pipe planning is very important. I'm not saying don't accept the same project again and again, same variety of project again and again, but it's equally important to be cautious on kind of work we are trying to develop and give it to the resources. To me, business is important, dollar value is important, but at the same time, people in the AI team are also equally important. As we discussed, AI engineers are scarce. AI and AI resources look for continuous knowledge improvement, and learning curve should be moving. So that's why work pipe planning is important here. And the second thing is plan for triple the capacity of tasks for each of the persons. So there is always a higher chance of facing a hard stop, or a kind of like a showstopper kind of thing when a person is working on developing one model or one part of the AI solution. So then he may say that, hey, I need so and so data for me to proceed further. In order to proceed further, so I can move ahead. So then he starts sitting idle, which is a costly thing, and we all know that AI resources are pretty costly. So that's why while making the project management or work planning for the team, it's always suggested to have like 3 times of capacity of the each resource in the team. And the next thing is we should have a continuous focus on tracking, helps in avoiding costly slippages. We discussed this one. Agile methodology and daily scrum calls are the best suitable for AI also, AI projects also. Same development can be tried with multiple resources. So this is another important factor that we should be looking at. There are different ways to get the development done, right? You have a requirement to be developed for say like in this week, and you call for a team meeting and say that, hey, I want to develop so and so thing, and the timeline is this week, and then you would take the ideas from everybody, you discuss it, and then decide like, okay, we discussed so many things, and let's try to go with the idea whatever is discussed in the room. But believe me, many a times, unless we go hands on, we don't know whether an idea is really good or not good, and all the resources may not have the complete idea of the approach that he is suggesting. He may be having a knowledge like a fairly to a decent level, but once he starts getting into the implementation, once he starts coding in hand, then he may be feeling a lot more information of the algorithm or the approach he has chosen. So I personally feel that you just disclose the requirement to be developed and let the people go along with their thought process. Let them go wild, right? Being wild is really, I feel it's a kind of to go way when we go with the artificial intelligence development activity. So that's why it is important here. Now we discussed so many other aspects, and now let's focus on the people management when we try to develop a artificial intelligence project. So team skill composition is really important. We need to have people with skill set like storytelling, visualization, exploratory data analysis, different technologies, business, and so on and so forth. When I say the technologies, it could be non-AI technologies or it could be AI technologies. And we also need to have a focus of research mind. I would say this research mind should be like common for every person to be eligible to be in the AI team. This is a kind of very important thing we should have. And uh, team should have kind of eagerness and try to learn new things continuously. That is really really important. They should not have a mindset of like being okay, I learned something, okay, that's fine, I have learned it. That's not the way it's going to work. And the team engagement and learning curve are, that's why important, because we are assuming that the team individuals in the team are very curious. Unless you feel like they are interested to work with you, you cannot get 100% engagement and quality. So that's why keeping the learning curve moving for individuals in the team is very important, and the team engagement as well. And a typical 8-hour work day of a AI engineer, if you see, it should be like a right mixture of research, practice, development, and fun. So that's why this right mixture is important to make the team engagement and learning curve moving. Now, so if you see this curve, bell curve, you can always feel that our AI engineers are not within 2 standard deviations of the mean. They are always innovators. That's why they are here in the industry at this time when the industry is still evolving. And when you feel they are innovators, they are scarce resources, they have a different mindset, and they are eagerness, they have a lot of eagerness and enthusiasm, and it's always important to keep them moving. So every project could be different, as I told, in terms of process, methodology, technology, budget, and skills. So we have to keep a close eye on engaging the people in the project. And keep every employee climbing the ladder, learning the new things, pipelines of tasks, whatever, like double the tasks or 3 times or whatever. Success is the killer of innovation. So this is an important thing in the business strategy when we try to develop any product or solution. It's a kind of important. When you feel like, wow, I have achieved, kind of like it gives a kind of like satisfaction, and then you feel like, oh, I have achieved, I don't need to run anymore. But it's a very subtle factor we have to handle when we try to manage the people. And the last but not least is, like we all know, all people are high performing folks in the AI teams. So if you look at this, yep. Yeah, sure. Okay, so and the next thing is we have a skill map here: data scientists, data engineers, developers, and domain experts. Not everybody are good at all the skills, so this is a kind of illustration where exactly it's going to be splitting across with respect to the skills scarcity of the resources and the knowledge level. And the next one is the client management. You should have a significant amount of R&D in all AI projects, which makes client feel unrest. So that's why it is important to give a daily update what's going on. And all clients are tough when it comes to AI because everybody keeps hold of budgets. And if you deliver something like a WMVP rather than MVP, they feel a lot more happy. So we discussed so many aspects, and now let's see if that's the kind of projects we are handling. What should be the ideal personality of a AI leader? He should be like ever student, never get satisfied, ability to live with ambiguity and confusion, because you never know when, what resource, who is going to come to you and saying that, hey, I couldn't proceed any longer. I have got some bottleneck or a hurdle. So that's a kind of skill set you should have. Ability to take decisions in the dark and ready to face failures, ready to take risks, multitasking, and yet focused. So that's one thing. And mindset of each AI employee is equally important because engagement of everyone is really important because it's an innovative and R&D oriented development activity. So it's a kind of meme when the leader feels that, hey, I'm so tired, and you will always find a situation like this, and you should have a lot of patience in handling the AI teams. So this is a kind of model that I propose, and I personally believe in this one. whatever the project that you are handling in the AI space, it could be a mixture of all these things: prediction, anomaly detection, natural language processing, optimization, and personalization. So the project could be any AI project, but it would be constituted with one or more of these five pillars. And when you are trying to work on this, you make capabilities along with the research, and capabilities are like reusable components which you develop once and use it across the projects. You may be doing a consulting, or you may be doing a product development, but this still remains the same. Along with the support functions of a business development and project management, you have the product delivered. Of course, everything is in the backdrop of the technologies like data science, machine learning, natural language processing, deep learning, big data, NoSQL. This is not the end of the list, but that's the backdrop of anything. All right, now it's we discussed so much, and it's time to call what action, right? So we have seen very interesting factors and aspects in the AI project, and yeah, let's see how we can implement and get something out of it. So these are like a few references I could share here with respect to the framework in the architecture we discussed, and ethics and AI. Pricing of AI project is again different from one person to the other person, but I find like one article which makes sense, and that's the thing even I have quoted here. Patenting process varies from one country to the other country. I just quoted a link here in Canada, but the concepts that we discuss is like very high level in the presentation. So I think that's all I have for now, and we can take up the questions. Suhas?
Thanks a lot, Shekhar, for your presentation. Um, it was very informative. Um, I I think there was a interesting discussion going on about patents and intellectual property, and I think one of the discussion themes was how do you protect yourself against patent trolls? I wonder if you have any insight on that. As a
Yeah.
small company, there is always the risk of you treading on the feet of big behemoth corporations, and how to navigate that space is it's a very tricky one.
Yeah. So I can understand the background why we are thinking about this topic. Most of the AI companies are like startups and all that. So I would suggest go early. Don't wait till the implementation is done. Go early. That's rule number one. And second thing is, don't patent only the technology. Let's assume you discovered a new architecture of a neural net which gives you a kind of awesome results. Don't wait for the technology. You may be looking for the application aspect. So this is the kind of application I'm looking at, and I'm not looking at the technology framework alone. Maybe today I'm trying to patent one technology, but if you patent an application, even if you change a little bit of difference, or even if you change a little bit in the architecture, in the innovation, your patent still holds good. So I would suggest go with the application rather than innovation of one specific technology. Otherwise, if somebody comes in your architecture, they're going to change like a couple of number of neurons or some hyperparameters. They're going to change it and say that, hey, this is my technology, not yours. So, but if you go with an application patenting, then you say this application is already patented with me. I would suggest that approach. I hope this answers the question.
Okay, thanks. Thanks a lot, Shekhar, for presenting this session. Um, to the audience, I hope you enjoyed it, and see you in the evening for a session on AI strategy, which will be presented by Amir and Hirsch Keshav. There will also be a session by Mario Kren at 12 p.m. EST. So stay tuned for that too. Okay. Thanks, everyone. and bye.
Yeah, thank you so much. Bye bye.